Hello, can you hear me?
Yes, good morning.
Hey, how are you doing, Catherine?
I'm doing pretty good. How are you?
Fine, thank you. Mr. Jawara, can you hear me, Mr. Jawara? And oh, sorry, Miss Jamara. Sorry. And Antoine. Okay, good. Excellent. Excellent. So let us give me one, let me check your names and we can start. Okay. All right, today we'll be looking at rounding up that section of statistical process control. We're working on it. So today we'll be looking at I'm gonna move this down a little bit. Yeah, control chart for attributes. Now, we classify the attributes in question into two main categories: the defectives and the non-defectives, basically. Yeah. So these are the the two kind of attributes that we look. We look at when we do control charts. Now, those measure those of the attributes that measure the percent defectives. In a sample, we use the P charts to examine them. Now, those that count the number of defects, you call it the C charts. But in general, measuring defective involve counting them. For example, in a manufacturing plant, we can count the number of bad light bulbs in a given lot. Then, or if it is a service company, we can look at the number of letters on the data entry record that are typed incorrectly, or data entry record that that type with errors on it. But with respect to variables, we're usually measuring their length or weight. So that's these are the two areas we're looking at, particularly the P charts. Now, let's see my screen. Everybody's in. Okay, good. Now let's look at the other information we need for this. We're talking about the P chart. Now let's look at the P chart. Now the P chart, we use P chart as a tool to control the attributes. As a quality control tool for attributes. Now note that the attributes that are either good or bad, follow. They follow. We assume that they follow the binomial distribution. Normal distribution can also be used to calculate P chart as well, because we can have a normal approximation of binomial. Okay. Anyway, I think you get the point. So, although attributes that are either good or bad follow the normal distribution, the binomial distribution, the normal distribution can also be used to calculate the P chart limit when the sample size are large enough. Given that statistically we have normal approximation of the binomial. So, and the method we use is similar to the method we use for the X bar chart, which is also based on the central limit theorem. Now, the formulas for P charts, we have it as both for the lower control limit and for the upper control limit are as follows. For the upper control limit, we have P bar plus Z delta P. I'll explain in a minute. Oh, excuse me, sorry. I clicked on something else. Now, for the lower control limit, we have P bar minus Z delta P, where P bar means the mean fraction or mean percent defective in the samples, which we can get by doing P bar equals total number of defects divided by sample size times the number of samples. Now, this value Z represents the number of standard deviations. And we use Z2. We use 2 for Z when we are talking about the 95.45% limit. And we use 3 for Z when we are looking at 99.73% limit. Of course, we know that the delta P is delta is the standard deviation. Now, for to find the standard deviation of the sampling distribution, we use this formula that you can see on the screen now. That formula is delta P equals square root of P bar times 1 minus P bar over N, where N is the number of observations in each sample. Number of observations in each sample. Now let us see how this works in reality. Look at this scenario that involves clerks at Mozilla Data Systems. They are required to key in thousands of insurance records each day for a variety of firms. So the CEO, Donna Mozilla, wants to set the control limits to include 99.73% of random variations in the data entry process when it is in control. Now, samples of the work of the 20 clerks are gathered and are shown in Excel. I can see them in Excel right here. The samples right here. Mozilla Data System. See, this is our work. The number of errors, then fraction defective, all gathered. Okay. So now we have that. The question says there. It said, Mozilla carefully examined 100 records entered by each clerk. So a sample of 20 clerks, then 100 records entered by each clerk, and count the number of zeros, so number of errors. She also compute the fraction defective in each sample. You are required to A, determine the number of the upper and lower limits with 99.70% confidence, and then you are required to plot the P chart using the control limit and the sample fraction of defectives. So these are the two things they want you to do based on this information. To do them, you first need to put the small statistics in Excel. I mean, there's one that's already there. As you can see from here, you will see that these are the Mozilla Data System sample number, a sample of 20 clerks. Okay, errors, the errors they committed. I mean, yeah, typographic error. Then fraction defective, they calculated it, and it says here. Now, total number of defects. How do I know the total number of defects? See, if you add all this, you get the total number of defects to 80. I can show you on the side. Equal sum. Okay, double click. And add all the defects. Okay, all the defects. Or to the last clerk. See, to the 20th clerk. And if you press the enter key, give you 80. So that's how we got this 8 here. Okay. Now, how many clerks? Sample size, we have 20 clerks. So I put right here, 20. Now, I remember that the question says that Mozilla carefully examine 100 records entered by each clerk, which means that the number of samples within each clerk is hundreds were examined. Now, do you want us to determine the upper and lower control limits? Okay, with 99.73% confidence. Then plot the P charts using the control and sample fraction percentage. Remember that for 99.73%, you got you use z equals to 3 for 99.73%. So don't forget that. That's why we have 3 inside here. Okay, I have to put a 3 right here. For 99.73%, I'm gonna put 3 there. Yeah. Now, p hat. These are the fraction percent defectives. So you can see the p hat. You can see the formula. I have it here too. See, number of defects divided by sample size times number of sample. Okay. So you have number of defects. P hat equals number of defects. Okay, which is 80 divided by sample size of 20 times number of sample. That means number of amount of sample examined for each pages examined for each sample of 20 clerical officers. Now you can close it, and that will give you the p hat 0.04. And you can see that I did the same thing here. You can see that I did the same thing here as well. See, 0.04. Now, let's get all this number before we can now finally answer the question. I say 1 minus p hat. Okay, gonna be 1 minus equals 1 minus p hat, which is 1 minus 0.04. Give me 0.96. Delta p. Let's calculate delta p. Okay, I'm gonna move some of this away so we can bring the formula closer. See the formula for delta p right here. Right here. Okay. You say delta p is p hat times 1 minus p hat over n. And it says the square root of p hat times 1 minus p hat over n. Let's do it from here for this one. So to put the square root on Excel, you're gonna put the equal sign, then type SQRT. See, it pops out here. Double click. Then you have p hat. Okay, which is right here. P hat times. Okay, say 1 minus p hat. We have 1 minus p hat right here. So I just type it right there. Okay. Now close it. Divided by n. Now n is 100. So of course you have to enclose it so that you can still have. Okay, I'm gonna make it double here because yeah, I have. Oh no, we have double. See, double closing parentheses. So we're gonna make this side double as well. Okay, so that it will balance. Excellent. Now press the enter key. Now that gives us answer 0.20, and I actually have it here as well. Okay. So 0.02, which is what I have here, 0.02. I see 0.02. I have 0.020. So let me just make it to the smart place here. 0.02. Now, with this, we can calculate our upper control limit, lower control limit. Then with that, we can now be able to construct the P chart. So I'm going to remove this formula, put it away so we can get the formula for upper and lower control limits. Okay. So if you look at the formula while we do it. This one here. Upper control limit, lower control limit. Okay, let's do it. Let's do it. Now, for the upper control limit, he said upper control limit is P. For this should be P hat. It's going to be P hat plus Z times DP. We already have our Z here and we have our DP right here. So all you have to do now is equals P hat is right here, 0.04 plus we got z times dp. Now z is 3 times delta p as the standard deviation, which is this one right here. Close parenthesis and press the enter key. 0.10. And as you can see, I also did it on paper here. See 0.10. Now let us repeat it for lower control limit, which is just to put the minus sign in between instead of plus sign. So it's gonna be equals p hat minus, okay, z times theta p. Z is 3 times theta p, which is 0.96. Oh, sorry, which is 0.02. Yeah. Okay. So we have p bar, which is right there, p hat. I'm going to call it p bar, not even p hat. P bar. Okay. Times, give me 1 minute to me for this number. Okay. Okay, that one here. P hat. Let's do it again. P hat, which is this one here, 0.04 minus z, which is 3 times delta p, which is right here. Press the enter key. They give me a negative number, so we cannot use a negative number. So what we're gonna do is just put 0 there. Okay. Now we are with this information, we have our control upper and lower control limits, and we have our p hats. What else do we need? And we also have our fraction defective values here. Now with these 3 things, we can now construct our p hat, because it says part B part of the equation says plot the p chart using control limits and the sample fraction defectives. So let us construct the p chart. Okay. Now to construct the p chart, we just make a few adjustments. Let me create a room for that. Okay. Now we are. Let me see how I can make this so it won't block my view. Okay, good. Now let us do this. So let's get our defective. Okay. Fraction defective stops here. I'm gonna go here. Put it so I'm looking for where I can put them. I need to remove all this so we can have room for this p chart. Let me remove all of them. Okay. Move them away. We have done with them. Need them for the calculation, and we did use them for the calculations. We'll move them away. Now we have a room for the p hat. P chart. So the fractional defective, I'm gonna take them from here. Okay. I'll go to the 20th clock. I'm gonna paste it right here. Okay. Okay, we have next is we have our mean as the p hat itself, the mean p hat. So I'm gonna put right here p hat. Okay, hat. I'm going to make it is point. P hat is 0.05. 0.04. 0.04. Okay. I'm going to make all these sections that I will use, make them to be font of 14. Okay. Make it font of 14. So you not be giving me all this, but I guess have a p hat holding. Then next is the upper control limit. Use UCL P. Okay. Now UCL and lower control limit LCL. Upper control limit. We'll have it as for our calculation 0.10, and lower control limit is 0. Okay. 0.10, 0.10, lower control limit is 0. So we're gonna copy this all the way to the last value for the fraction defective. So we're gonna copy all this down. I highlighted it. I'm gonna drag it down so that you can copy it all the way to the last of the last cell. Now with this, we can we'll draw the P chart. Now to draw the P chart, we start from defective, highlight everything all the way down. Okay. Once you highlighted it, you can click on insert and choose this line chart. This one. You can see the control chart right here. Okay. You can see it right here. And then let us add as this title. Fraction defective. Let me put it right there. Fraction defectives. Then you have the P chart. P chart for what company was it again? I think it was for Mozilla Data System. Mozilla Data Systems. Okay. Now here, this is the clock. Okay. And is it maybe 1 minute? Move this right here. This number of errors. Sorry, man. Number of errors. A mistake. Number of errors. Number of errors. Okay, let me make it bigger. I can have it. Make it bigger. So you can see, let me move it down so I can have enough room for it. You can see that actually it shows a process under control, except for this number 7, the 17th plaque. But you can see this is the upper control limit. This is the lower control limit. This is the p-hat average. Now you can see that everything, all the errors fall within the, within the upper and lower control limit, except for this clock number 17, where it went off. And that is why I wrote here. I wrote here on the PowerPoint that when we examine this, when we examine the we plot the control chart limit and examine it, we find that only one data entry clock is out of control. So it's a process. Their work is under control. Basically, let me put that way. So that one clock has their work not in control. But generally, when you look at it, you can see that this is actually showing. Apart from this, is a process under control. All the data points fall within the upper and lower control limits. Now, any question on this? Any question? Well, guys, any question? Hello?
No questions, but it is 11.
Okay, so you got, okay, good, excellent. So I think that's what we have today. And I will let you guys go. I will see you guys on Monday. Okay, enjoy your weekend.
Thank you, you too.
Bye-bye.
Did you drop the questions for the test?
They'll
Thank you, Professor Oba.
they'll be ready tonight. So check it
Okay.
again tomorrow morning. They're gonna be there. Okay.
Okay. All right, bro.
All right. Okay. Have a nice weekend once again. I'll
You
see
too.
you guys on Monday.
Okay.